So guys, our data ingestion component is ready. That means we are able to ingest that data from the URL. Now the next component we'll be writing called prepare base model. So as I already told you, so here we are doing actually deep learning project. That means image classification project. And we already know like inside image classification, we are having some pre-trained models. So if you want to see them, so simply go to the Google and you can search for Keras application. So here is the model list actually we are having inside image classification, and these are the pre-trained model. Okay, so this model is already trained with ImageNet dataset. So we are having exception which is in 16, 19, ResNet 50. Okay, so these are the model we are having, and you can see the model size as well, model accuracy, then parameter size. Okay, then the speed of the CPU, GPU. So everything is available here. So here, what I will do, guys, I will use one pre-trained model called VGG16. Now you can ask me why I'm taking VGG16, because if you have already worked with image classification, I think you know there are some architecture that will work actually better with most of the use cases. Like VG16 is there, 19 is there, ResNet 50 is there. Okay, then Inception is there, then efficient net is there. So these are the model actually works better with any kinds of problem statement. So that's why I'll be starting with the VG16, because it would be a little bit lightweight model for me. You can also take any bigger model. You can take Inception model. You can also take Resident model. It's up to you. Okay, you are feel free to use any kinds of model. It's up to you. So I'll show you how we can use the VG16 model, because if I show you one model only, you can use any of the model. Okay, so now you can ask me how to use this model. So you can simply open this link. So they have already given the code snippet like how we can call the model. Okay, so what are the parameter actually it is having. So what is the, let's say, input dimension. So everything they have written. You can see the input tensor. Input shape, it takes actually 224 comma 3. Okay, this is the dimension of the image. Now you can see it is also having the pooling parameter, classes parameter. So I don't need all the parameter. I'll be changing some of the parameter. I'll tell you. So these are the parameter we'll be writing in the params.yaml file. I think you remember. Okay, great. So now what we are gonna do here. Let me just try to explain in my Blackboard. So for this, what I have done, I have just taken this VG16 architecture. So I think you already know how to create this like custom architecture, okay, of any convolutional neural network. So these kinds of architecture, I think you are already familiar with, I'm expecting. So now let's try to understand what are we going to do here. See, here we'll be using the pre-trained model. Pre-trained model means we'll be using the pre-trained weights. So you can see this is the convolutional layer. So till here, this is called actually convolutional layer, conv layer. Okay, and here you can see another layer. So this is called actually ANN layer. Okay, artificial neural network, or you can also talk about dense layer. Got it? Dense layer. So what we usually do whenever we use any kinds of pre-trained model, we don't train this particular layer. Okay, this particular layer we don't train. So this will remain same. So we are not going to do anything. What we'll be doing, we'll be only changing this particular part. Okay, this part. That means we'll be removing this last layer. Okay, because last layer you will see the classes actually they're using, it is 1000 classes. Okay, the last layer, their number of classes they're having called 1000 classes. Why? Because they have trained with image net dataset, and image net dataset, how many classes it is having? 1000 classes it is having. But for me, how many classes we are having? Only 2 classes we are having. Yes or no? That means that coccidiosis affected fecal and that healthy fecal. That means 2 classes we are having. So what we have to do, we have to change the last layer with the help of our number of classes. So this is the idea of our image classification. Yes or no? Right? So this is what actually we'll be doing. That means we'll be using the pre-trained architecture, but at the last layer we'll be removing it. That means the ANN part will be removing it. Then we'll be creating our custom layer there with the help of our number of classes. And we'll be only training this part actually. This part will be training because this part is already trained. So it is already having like so many information. But if you also want, you can also train. These are the part. If you let's say I want to train this layer, you can also train. I want to train this layer, you can also train. Okay, I will also give the functionality in my code so that you can also pass like how many layer you want to train. Everything, it is possible. So now let's try to see how it can be done. So first of all, we have to get that VG16 model from the Keras. Then we'll be saving this architecture, okay, in our artifact directory. Then after that, we'll be creating our custom architecture. Then we'll be merging together. Okay, this is the idea. So let's get back to my code. So this is my VS code. So what I will do in the research folder, I'm going to create another file. I'll name it as 02 underscore prepare base underscore model. Okay, so first of all, let me select my kernel. Then I'll be executing the same code, I think, remember. Just to get back my project working directory. So let's copy and let me execute them. If I show you my project working directory, you can see I'm inside resource folder. Okay, so there is an error. It is telling pw command enable. Okay, so if it is not working, you can give this percentage symbol. Now I think it will work. Yeah. In case if this exclamation mark is not working, you can give percentage symbol. Okay. Now I'll copy this one, execute. Now if I again show you, I'm inside my project working directory. Okay. Now first of all, what I have to do, guys, I have to first of all create my configuration, because as per the workflow we know that first of all you have to update my configuration, then params, that entity, and so on. Okay, so let me first of all update my config.yaml. So inside that I'm going to mention my prepare base model related configuration. So this is the configuration. So here it will create a folder called prepare base model inside artifact. First of all, we'll be like saving the base model. That means the VG16 model will be downloading from the Keras application. Okay, then we'll save inside the artifact folder. We'll save inside the artifact folder. After that, we'll change the last layer. Okay, we'll be changing that particular dense layer with our custom architecture. Then we'll be merging that model, and this is going to be my base model updated.h5 model. And if you're using Keras TensorFlow, you have to save the model in a .h5 format. So yes, so this is what actually we have to write now. The next update we'll be doing inside params.yaml. So let me open the parameter. See, inside params.yaml, you have to mention all the parameters you will be using in the model. So these are the parameter I'm going to update here. So these are the frequently changed parameter, guys. That's why I'm keeping inside params.yaml. You can see. So here you can see, guys, I have written augmentation is equal to true. So Keras also provides augmentation functionality. Let's say you want to perform the data augmentation in runtime. It is also possible. If you are making it true, that means it will perform the data augmentation in the runtime. Otherwise, it won't be augmenting if you are giving it false. Then image size. Image size is a model parameter. You can see. So it is having the image size. That means input shape. Okay. That means this input shape of the image. It is accepting 224, 3. So this is what actually I have written 224, 3 as per the VG16 model. Now you can open up any other model and you can see the input size of that model. Okay. Then the batch size include top. Okay. Then number of epoch, classes, weights, learning rate. So these are the parameter we are already having here. You can see. Okay. Now why we are keeping this weight is equal to ImageNet? Because I want to download the pre-trained model, because it is already trained with ImageNet dataset. That's why we have to give this parameter. So it will give me the pre-trained model. Okay, now anytime you can open this file, you can change these are the parameter with respect to your requirement. Okay, that's why we are keeping everything in the params.yaml file. Now let me save. Now I'll get back here, then I'll create the entity. So I think remember we have to create the entity. So this is my entity, guys. You can see I'm like initializing all the, let's say, configuration as well as the parameter. Okay, you can see like params, image size, learning rate, include top, weight, classes. Okay, whatever actually I need, I'm initializing it here. Now let me initialize them. Then I'll be writing the configuration manager, I think remember. So after that we have to create the configuration manager. So for this I need, these are the import operation. Now this is my data prepare base model related configuration. So here I've created a class. This is my constructor. So here I'm reading the config file as well as the params file. And here I'm updating all the variables, you can see. So from params, actually we are updating for the parameter, and for configuration, we are updating for the configuration. Okay, that's it. Then we are returning it. Now let me execute. Then we'll be creating the final component. So prepare base model component we have to create. So let me import these are the library. So here Keras is already available inside TensorFlow. That's why you are importing TensorFlow. Now let me show you one final class I have created for the prepare base model. See guys, this is the class. So those who have worked with actually Collab notebook before, so see the same code I have written inside a class only. That's it. Now you can see this is my class prepare base model. Inside that I'm having one constructor, and this takes actually the configuration. After that, first of all, I'll be getting the base model. Base model means we'll be downloading this VG16 model, okay, from the Keras application. You can see this is the syntax. So the same syntax actually I'm using. Okay. Then I'm passing the parameter and all. Instead of hard coding, I'm taking from my parameters. Okay. That means from my configuration. Then after that, I'm saving the model. And how to saving the model? For this, I've created a function here. So here's the function, guys. Save model. So it will take the model and it will save that particular model in the H5 format. Okay. And this is static method because here actually whenever you are calling this function, you don't need to provide the self here. Okay. Because what is static function? Static means this function can be used by any other, let's say, class. Okay. There is no issue. So after getting the base model, I'm preparing the full model. That means now user has the functionality. So user will pass the number of classes they are having. So they want to freeze all the layer or not. Let's say if I want to freeze all the layer, it will freeze all the layer. But if you don't want to freeze all the layer, you can mention like how many layer you want to freeze. Let's say you want to freeze till here. Okay, till here you want to freeze. And these are the layer you want to train. So this particular number you can give here. Let's say you have given 5. So what will happen? Till 5 layer it will freeze. So 1, 2, 3, 4, 5. So till here actually it will freeze the weight, and rest of the layer it will perform the weight update, okay, during fine tuning. So this is what actually you have. Now learning rate, now you can see I'm preparing the full model. That means I'm changing the last layer, you can see gens layer, and number of classes I'm providing, and I'm giving the softmax activation function. Then after that, I'm compiling the model, because you know that if you're using Keras, so you have to compile the model. And this is my full model summary. After that, I have to update my base model. That means the model actually I have prepared. This model actually I have to update, I have to save. So this is what actually we are doing here. You can see I'm saving the model, okay, inside my artifact. Now this is the class I have prepared. Now let me show you how it will save the model. So for this, I'll call my pipeline. So this is going to be my pipeline. You can see this is my pipeline. So I'm getting the configuration, calling the component, inside that passing the configuration, get the base model first of all, then update the base model. Now see if I execute. So first of all, it will download the base model, VG16 model from the Keras application. Then after that, it will update my model. That means it will remove this part and it will add my custom layer. That layer actually I have added. So guys, as you can see, my execution is completed. Now if I open the artifact folder, now it has created another folder called prepare base model. Now if I open it up, you'll see that it has first of all downloaded my VG16 model. That means my base model. And this is my updated version of the base model. That means this is the model I will be using for my training operation. Okay. Yes. So great. It is working fine. Now let's try to convert this notebook as a modular coding implementation.